All right, we've made it to the final episode. Hope some of you guys have stuck along for the whole journey. If you haven't, and this is the first time tuning in, please go back and look at the last 4 videos, or you might be extremely confused at this point. So in the previous episodes, we've identified how to get access to the device. We've dumped the flash, we've re-uploaded the flash, and now we have persistent root access on the device. And now we're going to try to actually create some malware or an exploit that we can actually send to the device and have it potentially do all of this stuff that we've shown previously, all automated. So please stick around for the rest of this episode, and we'll hack this device together. So I'll catch you at the end. Okay, so this is what we want to hit right here. And so let's name this function to see. Okay, tar vulnerability. I want to see if this is called before or after. So let's, okay, so it's called after. So that's called right here. And our thing is up here. So it must have worked, but just failed so quickly within a second that we might have not hit it. But at this point, so that's getting called, like we could tell because it has the print message on it, that we could potentially, so it's going in, cding to that, and it's calling OpenSSL. What if we actually just overwrite OpenSSL with like a shell command, to do our stuff, like sleep, for instance, so it doesn't reboot. Let's try to find where OpenSSL is. So if we go to our find OpenSSL. So it's actually in the app bin OpenSSL. Actually, it'd probably be easiest to do this on the device. Let's log back in. Which OpenSSL? Of course. Find. Okay. So it's in temp bin. And so one thing that we have to be sure of is making sure where these things are actually writable. So we can run just mount and see that SD card is read write, temp is read write, app read only. So this mount app, mtd app, that's going to be read only. So we can't actually overwrite this one. So let's overwrite temp bin and hope for the best. So let's give that a go. So here is our Docker container again. And so we're going to remove the symlink to root. Could have left it, I guess. This will be easier though. So let's actually make a directory in temp bin and then symlink that and call that sim. So now we got sim pointed to temp bin, and now we can temp bin open SSL. So because we want to overwrite that, and we'll make this just a shell script. So we'll just start doing bin. Let's just make sure what. Bin ash. Yeah, ash is a good one to do. So we'll do bin ash, and then let's just see if we have sleep enabled on here. So sleep 10. Cool. Yeah, we have sleep. So we can do touch root. All right, what's this? Echo. Go root into hack.txt, and then sleep. Let's just do 122 minutes, and then since it's doing OpenSSL stuff, well, we can let it just exit out. I was wondering, we could change the return value here, so actually spoof that it actually verified in OpenSSL potentially, but we'll just leave it with, it will return the sleep return status, which will probably be 1 or 0, I mean, which is status successful. Okay, so now we have that. We'll add that to our tar. So tar cv sdf dot hack update.bin star, and then symlink OpenSSL. But before we do that, actually, we want to make sure that that's executable. So let's chmod plus x sim or tim and OpenSSL. So that will be, so when it calls OpenSSL that we just overwrote, it will be executable and won't have permission errors. So now let's run this command. Looks good to me. Let's move back over to here and encrypt it. Okay, so we encrypted it. Let's drag that new one over to the VM. Okay. Let me share that. So now, oops. All right, so now we have encrypted bin 1. So we have that set up. Okay. Go back to, I haven't clicked go yet, but I want to go back to here and do a watch root hack.txt. That is what we saved it as, right? Oh no, it's OpenSSL, jeez. Oh, but inside of OpenSSL. We are touching hack.txt, okay, with woot woot. So let's rerun this. I'm clicking system upgrade now on that device. So hopefully we don't actually, I could see here potentially that it's doing stuff. Hopefully we can see when it actually hits. Okay, there's the tar. It's hanging. connection closed. Oh, it like shut it down. But look, it's not rebooting necessarily, so if we log into here, hack.txt. So we have code execution. And so let's cat that out. Woot woot. There we go. So we just made a malicious firmware update. Overwrote the OpenSSL binary that is getting executed right after the code right after the tar gets extracted. And since it's a vulnerable version of tar, it can arbitrarily write files. So that is the CVE. That was it. And at this point, like, it is starting to reboot, but we can take it a little bit further. So, like, it is like, you can see that everything's getting shut down, like kill all, you know. Obviously, Telnet got shut down. So what we can do is actually turn that OpenSSL code execution into just persistent malware by using the ability to actually write the flash files. Yeah, let's just go through that just to put the cherry on top here. Okay, so now to try to get it to be persistent, we need to see how the whole update actually writes stuff in the first place. So let's go to our original the original update and see what how it was doing it. So original. Okay, so I think we extracted it all to here. So this write flash caught my eye. It's binary. Let's try to find that potentially in IDA. Okay. Go to the strings. Is there anything called write flash? Okay, so it's definitely like update before .sh. We don't have that. System firmware. So this is writing to the flash. Okay, so 0, I guess, means the first partition. Okay. So what is the second bit? Maybe write flash is documented on the internet. Man. No, that's just right. Okay, maybe not. What I'm thinking about doing is, since we have access to the device, right, through Telnet, we can see that the SD card is on there. So let me actually just pop the SD card out, put write flash on there, and potentially our modified squash FS image, and see if we can get that to write. Okay, let's plug the SD card into the computer. Okay. I'm going to drag write flash over. And then also I'm going to put our modified update bin, squash FS file. So that was in the dump, yeah. Hacked dump .bin. Let's copy that over. And actually, for sake of making it more real that we actually did something, let's actually modify that real quick. Instead of having it the same, let's actually modify it so we can actually tell if our write of flash actually worked. So mtd, and we modified this last time. Okay, with this. So let's go, since they were the same, hacked new. Okay, so at least, and then we'll print something below it too. So now we will know if this image actually got written, rather than us just uploading the same one and not knowing if it actually worked or not, because it just booted the one that we already reflashed using the Pi. So this way we can actually identify if it's working. So let's squash FS this. New. And then DD. Oh wait, we don't need a DD it into anything because we actually want just the squash FS potentially. And that is because if we look at the mount tables of, not the Docker image, of this, the squash FS is just one partition and it's on block 2. Okay. Good to know, good to know. So, yeah. Let's copy that over. So, new, squash fs, copy, paste. Okay, eject the SD card and plug it back into the device. Okay. Yeah, so in this hack utils, this is where I added our new squash fs and write flash. So if we write flash help, oh yeah, it has a help. Very good. Upgrade U-boot, you do write flash 0 source firmware file path file name. Okay. And we want to do 2 because we know that it's mtd2, and it is inside of the app directory. If we had the Linux file system, which was one of those other things that we saw in binwalk potentially that we didn't really extract. Well, we did at one point with the recursion, but we weren't able to precisely extract it like we were with the squash. Let's just continue modifying that squash. So we could do it now. Did it run our new? Nope. Okay, so yeah, it didn't work. So write flash is doing some more smart stuff that we don't want. We want just the plain old, easy to use, whatchamacallit. So open up another IDA. So this is the write flash. Let's see how it actually writes the flash. Pretty simple. But did it really open strings over there? That's weird. Oh, flash erase all. Fuser unmount flash CP. So is that actually in the on the device? I didn't see that. Oh, flash CP, there you go. Okay, so let's go back to our malware. So let's not do that. Let's do flash CP, or okay, fuser -k-m mount app ext. Let's do that for just app. Do we need to do the ext one? Let's double check just. Well, app ext. No, that's a completely different file. Yeah, let's forget about that one. So don't need this, don't need this. And we do, let's do flash erase all dev mtd 2, right? td block 2. Okay. And then flash cp temp fw upgrade. Oh god. Let's change it from new to like hack dot sqfs. I like that much. It's easier to type. Dev mtd 2. And let's just have this thing reboot right away. Reboot. Mod plus x that. All right. Oh, we need to add. So we have new. So let's remove right flash. We're not going to use that anymore. Move new to what? hack.squash. Okay. We should be in business now. Let's just list hack update bin. Why does it have new? Oh, because we copied it. We don't need to. Okay. Patch upgrade, hack squash fs, symlink to OpenSSL, which runs the command to write hack SFS to the file system. Whew. Hopefully this works. So now we need to encrypt it. OpenSSL, hacked update bin to encrypted. Nope. Okay, now we need to copy that to the other VM to upload it. Encrypted. It's a much bigger file this time. Speaking of size, how much space do we have on temp? Available 52 megs. Oh yeah, we're good. Okay. Well, here goes nothing. We have to do anything else. So we got the flash commands with our thing. We should, if it does work, we should see when it reboots that it changed that print message. So, all right, system upgrade. Here we go. I just clicked it. Let's sit back and watch. Okay. Looks like it's killing off stuff. Disable watchdog timer, I like it. Kill all. Extracting. Erasing. I hope this is only erasing the partition we told. Didn't really think of that. Okay. Hopefully now it's running the Flash CP in the background. So I guess we're just waiting for it to reboot now. Taking some time, huh? When we did it on the Raspberry Pi, write definitely took way longer than read, though, because it has to, like, it verifies the data, so I'm not too worried about this yet. So we'll see. Flash CP. This is taking a lot longer than I thought. I don't think it's working. Why didn't this command run? DD worked. I'm kind of afraid to reboot it. Maybe reboot's not a command. Whatever, I'm just gonna yank the power, plug it back in. Hacked new, woot woot. Okay, so I don't know why it didn't work by itself. Let's try changing the Squash FS one more time. And then let's just get rid of that flash CP. I don't know if that was the problem or if it was the reboot. Didn't seem like reboot actually worked, so like, is reboot even a command? Reboot, yeah. So if I type reboot here, why doesn't it reboot? Is there a way to use power off? We need the dash F on the reboot. Okay. Let's try this one more time. Okay. This thing's still spinning and booting up. All right, so. Yep. All right, so this is what we're gonna change. We're gonna do. Let's get rid of all these and do like something way more fun. Oops. At symbols. Oh yeah, that's definitely way more elite. Okay. Now we can tell if it's working from our script. Let's go back. Make Squash FS. Let's just change this to hack. Actually, let's just drop it right into the folder. Hack Squash FS. now we got the Hack Squash FS, tar. Oh wait, we do the tar in the Docker image. Okay. Then we know we need to encrypt it. Now we need to copy that over to the VM. All right. Hacked update 3. All right, so now. Oh wait, we never even changed. Gosh dang it. We never changed inside of the Docker image. We never changed this reboot. So let's just leave /cp. I don't know, that seems like the right way to do it. D0-F. Let's really get that thing going. Encrypt it. Copy the encrypted binary over again. So it's 4 now. Encrypted binary 4. Open. All right. Let's see if this thing reboots this time. Okay, just hit upload. Okay. Killing stuff. Extracting, erasing. DD went so much faster. Wonder if we should just DD it on there. Oh, it restarted. Okay, that wasn't too bad. Let's see if we get our @ symbols. Heck yeah. We did it. Fully automated, persistent remote code execution. There we go. All from, oh gosh, this thing is so deadly when it turns on. Yeah. Kind of a fun little project. Not the most technically challenging, but definitely enjoyed every step of it, that's for sure. It's one of the things that I like to do when I like to audit some of the stuff in my own house, that's for sure, and this was one of them. The fact that the username and password is by default sent over plain text now, at least I know that this thing can get hacked. So we've reported this to Foscam though, and so they're working on a fix. Should be, if you're watching this video, there is a fix out there. We wouldn't release it without that, But I hope you had a good time tagging along with this project. I kind of went through it back, like I haven't looked at it again, did some things differently this time. A lot of struggling, but that's kind of how hacking is. It's not our normal 30-second videos where everything works perfectly first try. That's definitely not how hacking is. It's very often to have things go wrong. Clearly debugging this thing quite a bit is definitely part of a normal research project. The fact that we got it to work, though, is all that matters. So there you have it. We have full remote code execution on this device. So we've, at this point, fully hacked the Foscam R2C IP camera and have now persistence on the device and can actually change or modify the flash partitions remotely. So I hope you guys all stuck around for this entire series. I appreciate it. This is our first one. Hopefully we can do more of these in the future. This was a really fun target for me. Like I said in the beginning, this is something actually I run in my house, so it's nice to know what kind of vulnerabilities or how good the security is on this. Foscam has done a great job of updating the software. They were in contact with us the whole time during the disclosure period and actually have created a patch version for this. So look out, if you have this camera, for the firmware version ending in 0.72. That should actually have a patch preventing this kind of exploit in the future. So thanks again for tuning in. My name is Sam. I'm part of Trellix's Threat Labs, and I look forward to interacting with you guys either on Twitter or the comments in YouTube here or wherever else this video may land. So you can find me on Twitter at EIP. I'll overlay that here. And talk to you guys later.